If we intend to enforce invariance, we shall need to mix a little bit of logic in with our types and a little bit of proof in with our programming. It is worth taking some trouble to set up our logical apparatus to maximize the effort we can get from the computer and to minimize the textual costs of proofs. We should prefer to encounter logic only when it is dangerously absent. Our basic tools are the types representing falsity and truth by virtue of their number of inhabitants. Dependent types allow us to compute sets from data. For example, we can represent evidence for the truth of some Boolean expression which we might have tested. A set P, which evaluates to 0 or to 1, might be considered propositional in that we are unlikely to want to distinguish its inhabitants. We might even prefer not to even see its inhabitants. I define a wrapper type for propositions whose purpose is to hide proofs. AGDA uses braces to indicate that an argument or field is to be suppressed by default in program texts and inferred somehow by the type checker. Single-braced variables are solved by unification in the tradition of Milner. Double braces indicate instance arguments inferred by contextual search. If just one hypothesis can take the place of an instant argument, it is silently filled in, allowing us a tiny bit of proof automation. If an inhabitant of so B is required, we may write bang to indicate that we expect the truth of B to be known. Careful positioning of instance arguments seed the context with useful information. We may hypothesize over them quietly and support forward reasoning with a therefore operator. This apparatus can give us, the traditional conditional, a subtly more informative type. If ever there is a proof of 0 in the context, we should be able to ask for anything we want. Let us define magic using AGDA's absurd pattern to mark the impossible instance argument, which shows that there no value need be returned. For example, instance arguments are not a perfect fit for proof search. They were intended as a cheap alternative to type classes, hence the requirement for exactly one candidate instance. For proofs, we might prefer to be less fussy about redundancy, but we shall manage perfectly well for the purposes of this paper.